Hello everyone. In this question, it is asked that if alpha beta be two distinct values of x in the closed interval 0 to pi, for which square root 5 times sine x, 10 sine x, and 10 times 4 sine square x plus 1 be three consecutive terms of a geometric progression, then we have to find the minimum value of alpha minus beta, the minimum absolute value of alpha minus beta. Okay. So we are given three terms: root 5 sin x, 10 sin x, and 10 times 4 sine square x plus 1. And we are told that these are three consecutive terms of a GP, right? Are in GP. And we are given that x lies in this closed interval 0 to pi. Okay. So if these three terms are in GP, then the square of this middle term will be equal to the product of the two extreme terms, right? So this implies that 10 sin x whole square is equal to the product of 5 root 5 sin x times 10 times 4 sine square x plus 1, right? So from here on simplifying, this gives us 100 sine square x is equal to 10 root 5 sin x times 4 sine square x plus 1, right? So we can cancel this 10 with this 100, right? So we have 10 sine square x in the left hand side right now. Okay. And we can also eliminate a sin x, right? We can cancel one sin x from the left hand side with this sin x. This is because since sin x is not equal to 0, because if sin x is equal to 0, then these three terms, all of this will become 0, root 5 times 0, this will become 0. So then this condition for GPU will be invalid, right? It becomes 0 upon 0, which becomes meaningless. So sin x is not equal to 0. That's why we can cancel this sin x from both sides. Okay. So now we are left with 10 sin x is equal to 4 root 5 sin square x plus root 5, right? So let us take all these terms to the right hand side. So this becomes 4 root 5 sin square x minus 10 sin x plus root 5 is equal to 0. Okay. So on trying to solve this for sin x, this is a quadratic equation in sin x, right? So if we use the quadratic formula, this becomes minus of minus 10 plus or minus b square, that is minus 10 whole square minus 4 times 4 root 5 times root 5, right? This is 4 AC and this is divided upon 2 times 4 root 5, right? Minus b plus minus b square minus 4ac upon 2ac, right? So on further simplification, this gives us sin x equal to 10 plus minus, this will become 100, and this will become 4 times 4 is 16, and root 5 square becomes 5, so 16 times 5 will become 80, right? So this becomes 100 minus 80 upon 8 root 5. So this becomes 10 plus minus, this is root 20, right? So root 20 is nothing but 2 root 5 upon 8 root 5. So if I multiply both this numerator and denominator with a root 5, this will become 10 root 5 plus minus 2 root 5 times root 5, this will become 2 times 5, that is 10 upon 8 root 5 times root 5, this will become 8 times 5, so this becomes 40, right? So this gives us sin x equal to This 10 root 5 upon root 40, this will give us, on dividing by 10, this will give us root 5 plus or minus 1 upon 4. Okay, so these are the two values which are given to be alpha and beta, right? So let alpha be this value, right? Root 5 plus 1 upon 4, and let beta be the other value, that is root 5 minus 1 upon 4. Okay, sorry, not alpha, this has to be sin alpha, since this was a quadratic equation in sin x, not x, right? So these two values have to be distinct values of sin alpha and sin beta. Since we are solving for sin x, this has to be sin alpha and sin beta, right? We are not solving for x here, we are solving for sin x here. So these are the two values of alpha and beta that we have got. Okay, and we are given that these two values are in this closed interval 0 to pi, that is up to the second quadrant, end of the second quadrant, right? So these two values of sine are not common. Okay, these are very like not so standard angles, but these two angles, this first angle, if you look for the acute angle, this is equal to sine of 54 degree. Okay, sine of 54 degree can be also written as 3 pi upon 10. And similarly, this angle, this is actually sine of 18 degree. Okay, 18 degree means this becomes pi upon 10. Okay, so these are the two acute angles. Okay, if you want their derivation, I can show you. Sorry, this is rough. Okay, rough work. We have to find the value of sine 18 degree equal to sine pi upon 10, right? Okay, so if I take theta equal to say pi upon 10, 18 degree, this will imply that 5 times this value, 5 theta, will be pi upon 2, right? That is 90 degree. Now this can be further simplified as 2 theta plus 3 theta is equal to pi upon 2. So on changing sides, this gives us 2 theta is equal to pi upon 2 minus 3 theta, right? So on taking sine of both sides, this will give us sine 2 theta will be equal to sine of pi by 2 minus 3 theta. So this gives us sine of 2 theta is equal to cos of 3 theta, right? Pi by 2 minus theta is cos theta, right? So on further simplification, this gives us 2 sin theta cos theta is equal to 4 cos cube theta minus 3 cos theta. So if I take cos theta common from here, this will give us cos theta times 4 cos square theta minus 3. So this cos theta and this cos theta can be cancelled because cos theta is not equal to 0, right? Cos theta is 0 for 90 degree. Here it is 18 degree, right? Theta is 18 degree, pi by 10. Okay, so cos theta can be cancelled from both sides. So this gives us 2 sin theta, and this cos square theta can be written as 4 times 1 minus sin square theta minus 3. So this on further simplification, this minus 4 sin square theta, if I take it to the other side, this will become 4 sin square theta plus 2 sin theta, and this is 4 minus 3 is plus 1. If I take it to the other side, this will become minus 1, right? So from here we have to find the value of sin theta. So sin theta will be nothing but minus 2 plus, here since sine 18 degree, this is acute angle, right? And this value of sine in the first quadrant is positive, right? So this has to be the positive root here, this won't be the negative root. Okay, so we are only taking the positive root here since this is an acute angle. Okay, so this will be Sin theta equal to minus 2 plus this b square, that is 2 square, minus 4 times a is 4 again, and c is minus 1, right, upon 2a, that is 2 times 4. Okay, so this will give us the value minus 2 plus this is 4, and 4 times 4 times minus 1, so this will become plus 16. Plus 16 plus 4 is root 20, right? So this becomes 2 root 5, 2 root 5 upon 8. So this becomes sin theta is equal to minus 1 plus root 5 upon 4, right, on dividing by 2. Okay, so this was the value of sine 18 degree, that is sine pi by 10, right? So this is the value of beta, sine beta here, right? Now this is the value of sine 54 degree, sine alpha. Okay, so let us also find that one. Okay, so this is first part. Okay, this is one. Similarly, now we want to find the value of sine 54 degree. Okay, now for sine 54 degree, instead of finding the value directly, let us try to find the value of cos 36 degree. Okay, cos 36 degree, which is nothing but cos of pi upon 5, right? Okay, now this is cos pi upon 5. This is nothing but cos of 2 times pi upon 10, right? 36 degree is 2 times 18 degree, right? So this is cos 2 theta. Now cos 2 theta can be written as 1 minus 2 sine square theta, right? And we already know this value, sine pi upon 10. This is the value. This is equal to sine pi upon 10, right? So we can use this value here directly. Okay, so this gives us 1 minus 2 times, this is root 5 minus 1 upon 4 whole square. So this gives us 1 minus 2 times, on squaring this numerator, this will give us 5 plus 1 minus 2 root 5 upon 4 square is 16, right? So this becomes 1 minus 2 times 6 minus 2 root 5 upon 16. So if I take the LCM here, this will become 16 minus 2 times 6 will become 12 plus 2 times 2 root 5, this will become 4 root 5 divided upon 16. So this becomes 4 plus 4 root 5 upon 16. Okay, so on dividing both numerator and denominator by 4, this becomes 1 plus root 5 by 4. Okay, but this was the value of cos 36 or cos pi by 5, right? We wanted to find the value of sine 54 degree. Okay, so now sine 54 degree, which is equal to sine of 3 pi upon 10, right? This is 3 times 18 degree, and 18 degree is pi upon 10. Okay, now this angle, this can be written as sine of pi by 2 minus 2 pi by 10, right? This is 90, and this is 2 pi by 10 is nothing but pi by 5, that is 36 degree, right? So 90 minus 36 is 54, right? Okay, so this implies that sine 54 degree, which is equal to sine 3 pi by 10, is equal to, this is sine pi by 2 minus theta, that is sine 90 minus theta, so this becomes cos theta, right? So this becomes cos 2 pi by 10, which is nothing but cos pi by 5, right? So this implies that sine 54 degree, which is sine 3 pi upon 10. This is cos pi by 5, which is nothing but this cos pi by 5, right? This is the value. Root 5 plus 1 upon 4. Okay. So if you know these two angles directly, no need to do all these calculations. Okay. I did it because I wanted to show this. Okay. If you do not know this, you can derive this, but it is better if you know these two values directly. Okay. So we have got sine alpha and sine beta as 3 pi by 10 and pi by 10. Okay. So we continue from there. Sine alpha is equal to sine 3 pi by 10, and sine beta is equal to sine pi by 10, right? But we are given that alpha beta lie in this up to second quadrant, up to pi, right? So these are the acute angles. Now for the obtuse angle, this can also be written as sine of pi minus 3 pi by 10, right? So this becomes equal to sine 7 pi by 10. Okay, this is another angle. Similarly, for this pi upon 10, the obtuse angle will be pi minus pi upon 10. So this will become equal to sine of 9 pi upon 10. Okay, so finally we get alpha equal to 3 pi upon 10 or 7 pi upon 10, and beta equal to pi upon 10 or 9 pi upon 10, right? These are the four possible angles. Now we have to find the minimum value of the absolute difference of alpha minus beta. Okay, so there are going to be four possibilities, right? So possibility one, where we take alpha beta equal to say these two pairs, 3 pi upon 10 and pi upon 10. Okay, so this implies alpha minus beta will be equal to this minus this, so this becomes 2 pi upon 10. So the absolute value is equal to pi by 5, right? On simplification. Similarly, for the other pairs, we can take 3 pi upon 10 as alpha and beta as 9 pi upon 10. So alpha minus beta, modulus of alpha minus beta now becomes 3 pi upon 10 minus 9 pi upon 10, which is modulus of minus 6 pi upon 10, which becomes 3 pi upon 5 on simplification, right? So already this pair is larger, the difference is larger than this. Okay, so this will be excluded. So let us look at the other two possible pairs of alpha beta, right? So we have already taken 3 pi by 10 two times. Okay, so now the two pairs will be alpha for alpha equal to 7 pi upon 10. So we take the pair 7 pi upon 10 and beta equal to pi upon 10. And on doing alpha minus beta, this will be 7 pi upon 10 minus pi upon 10. So this is just 6 pi upon 10. So the modulus will be the same as normal value. So this is again 3 pi upon 5, right? So we see so far pi upon 5 is the smallest value. Okay, now let us look at the last possible pair, which is alpha beta equal to 7 pi upon 10 and 9 pi upon 10, right? So now alpha minus beta becomes 7 pi upon 10 minus 9 pi upon 10, which is modulus of minus 2 pi upon 10. So which on further simplification gives us pi upon 5. Okay, so we see there are two values of pi upon 5 and two values of 3 pi upon 5, and this is the smaller value, right? So we were asked to find the least possible value of modulus of alpha minus beta, right? So we see the least possible value happens for 3 pi upon 10 and pi upon 10, or 7 pi upon 10 and 9 pi upon 10, right? These are the two possible pairs of alpha and beta. Okay, so alpha minus beta minimum value is pi upon 5. Okay, and this is the required answer. Okay, this is the required final answer. I know this was a very bit lengthy video. If you know these two angles, the values of these two angles, okay, you can skip this entire part. But if you don't know these values, then you can see this part once and you can use this. Okay, if you know this, it is very good. You can do this directly. Okay, and it will save us some time. But if you are doing this for the first time, then it is good that you practice these values and try to remember this tricky angular values of sine and cos. Okay, this will be sometimes beneficial, you never know. They might be given in the question also, but sometimes these values are not given and you are required to memorize these values. Okay, so this is it. Okay, if there is any doubt in any step, you can highlight in the comments. Okay, thank you.